I am super excited about this next topic. Do you believe in love at first sight? Well, I can tell you the exact moment I fell in love with my wife, and I can tell you the exact moment I fell in love with finance. It was the spring of 1996. I was sitting in a first year MBA class at Michigan State University, and Professor John Gilster was presenting this very subject. I found it elegant, beautiful, contrary to what I had expected to see, and utterly useful in real life. I was hooked. If you want to learn more about portfolio theory, stick around. The old adage of not putting all of your eggs in one basket is the basis for portfolio theory. The underlying idea is that by diversifying your portfolio, no single asset can destroy the entire portfolio. Even if one stock tanks, it is likely that the others will not do as badly, and some may even benefit from the event that caused the first stock to fall in value. While that is not always true, it is true for idiosyncratic sources of risk because, as you know, idiosyncratic risk relates to a specific firm and not the broader market like systematic risk does. Even if you put your eggs in different baskets, there's still no guarantee that you won't break both baskets of eggs. In other words, diversification is a good risk reduction strategy, but it does not completely eliminate the risk associated with investing. If there's one thing I want you to take away from this class more than any other, it is the idea that your investments should be as diversified as broadly as is reasonably possible. The second thing I hope you remember long after this class is over is that your choices of investments should be as uncorrelated as possible. When we combine assets in portfolio, the return on the portfolio is a simple weighted average of the returns on the components of the portfolio. In other words, if you invest 60% of your retirement account into a stock, let's call it Ladder World, that earns 25% this year, and the other 40% in a stock that we will call Travel Products Incorporated, that loses 5%, your overall average return on the portfolio is 60% times 25% for Ladder World, plus 40% times a 5% loss for Travel Products Incorporated, or 13% overall. The same weighted average calculation applies to the beta of your portfolio. So if Ladder World has a beta of 0.8 and Travel Products Incorporated has a beta of 1.3, the overall beta of your portfolio would be 0.6 or 60% times 0.8 plus 40% or 0.4 times 1.3, or a beta of 1. But what about for idiosyncratic risk? Imagine Ladder World has a standard deviation of returns of 20%, and Travel Products Incorporated has a sigma of 15%. You might be tempted to take 60% of 0.2 and add that to 40% of 0.15 to get a portfolio sigma of 0.18 or 18%. But that would be wrong. In fact, we don't even have enough information yet to compute the standard deviation of the portfolio. We need to know how these two assets are correlated. Let's say that the correlation coefficient, typically annotated as rho, is only 0.35. The formula we will use here is sigma sub p, or the standard deviation of the portfolio, is equal to the square root of, all in parentheses here, the weight of asset A squared times the standard deviation of asset A squared, plus the weight of asset B squared times the standard deviation of asset B squared, plus, and this is the beautiful part right here, 2 times the weight of asset A times the weight of asset B times the correlation coefficient of A and B times the standard deviation of A times the standard deviation of B. I know that seems daunting, but let's break it down and plug in the numbers that we've been working with. In this example, the weight of asset A is 60%, and the standard deviation of asset A is 20%. Meanwhile, the weight of asset B is 40%, and the standard deviation of asset B is 0.15 or 15%. The standard deviation of the portfolio is the square root of 0.6 squared times 0.2 squared plus 0.4 squared times 0.15 squared plus the number 2 times 0.6 times 0.4, those are the weights of the two assets, times 0.35, the correlation coefficient between the two, times 0.2 times 0.15, and so take the square root of that whole entire thing, or in other words, 15.1%. So by putting these two investments together in portfolio, we knocked off 2.9% from the standard deviation without reducing the average returns at all. That is the beautiful part here. That might not seem like much, but what has happened to the Sharpe ratio? If we assume the risk-free rate is something like 3%, the Sharpe ratio, using a sigma of 0.18, would be 0.55, simply 13% minus 3% divided by 0.18. That's the return on the portfolio minus the risk-free rate divided by the standard deviation of the portfolio when we just took the weighted average. However, because of the benefit of diversification, the Sharpe ratio at a sigma of 0.15 is actually 0.67, which is quite a bit better than 0.55. So you can see that because these two assets are not perfectly correlated, combining them in portfolio improves the overall performance of the investment just because of the risk reduction associated with splitting our eggs across two different baskets. In the 1950s, Harry Markowitz, while still a PhD student in economics at the University of Chicago, began to ponder the benefits of diversification. He even wrote his doctoral thesis on the subject. At the time, Milton Friedman, perhaps the most famous economist in history, rejected the paper Markowitz had wrote and said, "This isn't even economics." The paper was so heretical it didn't even get published for several years afterwards. However, 34 years after he wrote it, it won him the Nobel Prize in economics. I feel like there might be a lesson there in grit or something.